Aren't you guys sad? It's our last class. But I managed to find an emoji that's like sad, but also happy. Yeah. I felt like it perfectly summed up this kind of this course, ending this course. It's sad because I'll miss you guys, but it's always nice to finish a course. Okay, so it's our last class today. Oof. Do that. So I know, can't believe it. It's crazy. Okay, and I keep forgetting to ask you guys to do yeah. Finally. And so I keep forgetting to ask you guys to do my evaluation. So I've been half assuming that the college has been asking you to do it, but I've never asked you, so because I keep forgetting, but it closes on Friday. So I'll show you where to go, but please do my review. Oops. Hey. Whee. Please do my review. It closes on Friday. I'm going to see if I can see a time on, but otherwise I think it just says it closes on Friday. So if you're not sure, oh, you haven't. Okay. Well, that's weird. How are you supposed to know if you're supposed to do them? Anyways, so, okay. Tomorrow. Oh my gosh. In my mind, I thought it was Wednesday. Crazy. Okay, so to show you what you have to do, they're not that bad. If you've had in-person classes, which was a long time ago now, but you'll remember there's those bubble sheets. And so on my Moodle dashboard, this is what my Moodle dashboards looks like. I don't know what yours looks like, kind of depends. But over on my left-hand side, I have formative evaluation of college professor. So if you go there, then there's instructions, which I encourage you to read, but it's really just going to tell you what to do. It says it takes approximately 25 minutes. I really don't think it will, because it never does. They're assuming that you're writing a ton, but I'll show you what I care, the parts I care about and the parts that are just nice to have. Yeah, so here it says option 1, you'll be able to access and complete the survey anytime before December 3rd. Now, I would love to give you time to do it right now, but we've got kind of an important day coming up here, so I'm not going to do that. But if you could make a little bit of time, that'd be great. So I'll show you what it is, so it's not so scary. So there's a survey link at the bottom for the fall. And so you're going to hit that because we're in the fall term. Oh, sorry, I was showing my other class. Hey, how do I? Okay, so then this should come up. And then, so you read that, of course, and then you hit next. And then you're going to select me. But it's possible that you have other professors who have to have them done as well. That's usually the case. And so that's why I'm so surprised that the college, because they're the ones who care about this. I mean, they're nice to have, but they love having them. So you find me in the list. And then you pick the course. Of course, we're Stat 240, but I have to do them for all of mine. So if you are in my data science, or then you have to do both, or ideally you can do both. So if you hit Stat 240, and then you hit next, okay. And then there's a series of multiple choice questions ranging from strongly agree to strongly disagree or not applicable. And some of these you're allowed to score me very low because it was a complete disaster with the old textbook, but I feel like we righted the ship. So anyways, but that's okay. So just fill in. So these bubble portions, those are the ones that I care about. And on the iPad, it looks like a long list, but it's really not that bad. At the bottom here, there are boxes for you to type up, comments for me. So these go to me, and but you don't have to, because they just go to me, and I do find them helpful, and I do think they're great. But I also know that when I had to write them, it would take me quite a bit of time. And so I don't want you to feel like, oh, and then I have to write that blurb for Emily. No, you don't have to do that. All I care about really is those, the bubble parts. Okay. And then you can leave the rest blank. Okay. And then you would submit it, and then it's done. Okay. So not sure what time on Friday, it still didn't say, but tomorrow. Yeah, so the link is, it's on the Moodle page. So if you go to your dashboard, your Moodle dashboard, it might be in your current courses, or it's over on my left-hand side. It says formative evaluation of college professor. But what I'll do, I'll send out an announcement as a reminder, and I'll try to include the link, or at least a description of where to find it. Oh, and that's very nice of you to say. And totally, we have a department meeting, and I'm gonna yell at some people. So anyways, yeah, so we'll see, but that doesn't help you guys. All right. So let's see here. Test number 2 will be available tomorrow. And so my idea was that you could use the lab time that you have in your schedule, because you should have lab time available. You don't have to use that time, but I wanted to make it a 50-minute test so that if you were on, a crazy schedule, then you could use that lab time to do the test. But it'll be open between 7 and midnight tomorrow. And once you start, you'll have 50 minutes. And I've got some details. Maybe I'll go through the test 2 details first, and then we'll wrap up the logistic regression notes that we were talking about last day. So test number 2 will open tomorrow at 7 o'clock PST, in case that's unclear, and close at 11:59. And close at 11:59 PST. Okay. It's going to be a 50-minute timed quiz. $50-minute timed quiz or test or whatever you want to call it, doesn't matter. With 1 attempt. Okay. Sometimes, so I don't need you to submit any work, but it might be a good idea to just jot down the answers that you're submitting as you go. Okay, so just keep a record of your attempts, or sorry, of your answers, because if you see that once you've submitted, you see that some of them didn't submit or whatever, that doesn't happen, but just in case it has happened in the past, but then students realize, oh, I did this wrong, or oh, I didn't submit it, or whatever. So just to have a record of your responses, then what I want you to do is just jot them down. And then if it comes up, then, you know, you can send them to me and as soon as you can, and then I can make adjustments. So the quiz is very similar to those assignments. And so you should use those as a practice test. Okay. 50 minutes, one attempt, and I'll use back to blue here. Use the assignments posted. Get to that. Use the assignments which were on simple linear regression, multiple linear regression, and logistic regression. As practice for the test. Okay. So there will be from simple linear regression, there are 3 questions. From multiple linear regression, there will be 7 questions. Some of them are relatively quick and some of them are a little bit more involved, but you'll see that in those assignment questions as well. And so that's the breadth that I'm expecting. And then for the logistic regression, there will be 2 questions. And it'll be a total of 51 marks, but I'll make one of those a bonus. So it doesn't matter, there's no bonus question, but if you get 51, then you'll have 51 out of 50, which is nice. One mark will be made a bonus mark, just so it's nice and even out of 50. Okay. I don't know why I said 50 is even, but anyways, so that's what you should expect, and definitely go ahead and look at those assignments, and then you'll have a good idea of what the questions are. Okay, and then as a follow-up, I'm gonna try to program the test 1 questions in this interface and see how I do. But in that case, I will post practice questions so that you can see them in this interface, because we had them just on paper. And I'm gonna have to call Steve probably for a little bit of help with the programming. But that's my goal for the final exam. So our final exam, yikes. So the final exam is going to be, I'm trying to make it similar to test 2. It's basically going to be test 1 and test 2 together. And so our final exam is on Wednesday, December 8th, less than a week away. Oh my gosh. from 9 to 12 PST, okay? And it'll be a combination. So basically it'll be, one thing I wanted to say, just to keep you guys on your toes, they won't be in order. They will not appear in order. Okay. That's a good thing for you guys. The reason I felt like I should do that is because these questions are, I'm going to say, really easy. So that's why I wanted to mix it up. Otherwise you get too much in the groove and you're like, okay, now it's going to be a multiple. Okay, now it's going to be a logistic, but you'll be able to pick up on it pretty quickly anyways. So the final exam is going to be test 1 and test 2 combined. Test number 1 and test number 2 combined. Okay. In format, it'll be similar to test number 2. But like I said, I'm going to have to program test number 1 questions. And so I don't know how many questions it'll be. We do have 3 hours. I like to make a 2-hour exam. So, so in length, you know, think test 1 and test 2 together, and that's a pretty good guess. And so it'll be test 1 and test 2 combined, and in format, similar to test number 2 in format. But I will get you to submit work for 1 or 2 questions. And maybe for the final exam, I'm trying to keep it on 1 page, but maybe to free us up here, I'll put it on a fresh page. So similar to test number 2 in format, with written work submitted for 1 or 2 questions. I'm kind of leaving it open. So you'll have to submit your written work to Gradescope. And once I've kind of hammered down the programming is what's scary to me. I got to program these questions. And so once I hammer that down, I'll send out an announcement so that you guys have a good outline of what to expect. But that's it for in terms of material, you know, focus on test 1 and test 2. And as long as you know that, then I'm happy. Okay. Is there anything I've forgotten or anything else you want to know about before we keep going with logistic regression? Oh, do you mean the final exam? It's from 9 to 12. So just like test 2, yeah, I'm supposed to watch you guys. I don't really see what the point is in watching you. So I will be in the Zoom room. So for the final exam, of course, because test 2 is open kind of anytime during the day. So, and I'll be driving tomorrow. So that's what makes it kind of tricky. But if you text me, I'll be able to help out, I suspect. For the test, for the final exam, maybe I'll say final exam. I will be in the Zoom room in case you have any questions, but I am deciding to treat you all like adults, and You do not have to be in the Zoom room, but I want to be available if you have questions. But I know that it's a lot calmer if you don't feel like someone's watching you, and so I want to give you that. Okay, so no cheating, obviously, but it is open book, so you're allowed to use all your resources, just not each other, right? And so so I'll be in the Zoom room during the exam. But you do not need to be there. Yeah, I know. So yeah, someone watching you as you're doing the exam, it's really stressful. And it kind of adds another layer of stress that you don't really need. It's a final exam, that's stressful enough. And so for my higher level classes, I'm deciding that no, you guys are all adults, and you know what's appropriate and you know what's not appropriate. And so I trust that you'll do the right thing there. Oh yeah, everyone else can just watch you. They're all busy watching themselves, but no, so okay, so yeah, I guess I should add in case you have any questions. Yeah. So you don't need to be there, right? The exam, just like the tests is open book. The exam is open book. Okay. So you're allowed to use all your resources except each other. You may use all your resources except each other. How about that? Oh, well, yeah, so each other / cheating sites. But that, yeah, it feels obvious, but I guess I have to say it, / cheating websites. I'm gonna highlight that too. Feels important. Okay. But like I said, you have a pretty good idea of what you're allowed to do and what's bad. And so just keep that in mind. Okay. I think we're ready to get into some more logistic regression. Can't quite remember. If you think of any other questions that you need me to clarify, let me know. But otherwise, I'll go see where we ended up. Can kind of think about it. Where did we get to? Haha. Oh yeah. Okay. Oh, we got to our beautiful S curve. Okay. How can I copy? Let's see here. Select. I'm gonna copy. Dun. Copy. Okay. So in terms of a recap from last day, I guess paste. Okay. So, oh, I need the model because I wanted to recap all of it. We worked through and we figured out well, first we figured out that the units must be in centimeters and not not inches like I had put. But you guys were caught on to that really quickly. So let's see here. Review from last day. So we're looking at the relationship between the regions that a possum is found in or lives in and the tail length of the possum. Okay, so we had the regions, they were coded as dummy variables. And as soon as we have a dummy variable, well, that means that we have a categorical variable. And when the categorical variable is the outcome, so is the response, then we need logistic regression. Okay. So what we said was, okay, well, to fit a logistic regression model, we use the generalized linear model. Okay, function. So it's the GLM function. You've seen the LM function. And so now here's the, that sounded like an ad. You've seen the LM function. Now consider the GLM function. And I guess kind of. But if we're building a logistic model, then we say that the family is equal to binomial. And we would be able to change this to other families if we wanted to consider other families. But for us, we're going to focus on just logistic regression. Okay. And so we use, here I'll say, we use logistic regression to model a binary response. So a binary, which means it's categorical, right? And that's what helps me remember, model a binary or a categorical response variable. What I think can get confusing sometimes, or maybe I'm the only one, but I remember learning this stuff and being really confused by, well, the tail length is numeric or it's numerical. So how can I use that to predict some categorical outcome? And so you have to remember that, okay, so we use linear models. We've used linear models. There are other models, but we've used linear models because they cover a lot of ground. A lot of the scenarios that we have are linear. So we use linear models when we're trying to model a numerical outcome, right? And so logistic regression is when we're trying to model a binary outcome. And so it's just about the y, right? Is y numerical or is it categorical, right? Or binary. Okay. And then the x's can be categorical or numerical or both. We can have combinations of them. They're allowed to be whatever we need them to be. Okay, so it really only hinges on what the y is. Okay, so recall, if y is numerical, use linear models. And if y is, let's broadly say categorical, use logistic regression. Use logistic regression. Oops. Okay. Just as a reminder to keep them straight. Okay. So we built this model and we called it logmod. We need to store it somewhere so that we can use the summary command to look at what actually happened in the logmod. Now you can write logmod, but I'm pretty sure it would only give you the coefficients and nothing else. Okay, so you want to use the summary command, but before you can do that, you have to build your model. And so we use the GLM function, the generalized linear model function, and we have the format of y tilde x. Okay, you can use the possum $. We had created these dummy variables, so pop dummy and possum $ tail length. Then you wouldn't have to say data equals possum, but it's a little bit cleaner if we tell it what data set to use kind of separately. And then we tell it that the family is binomial, and that's what makes it a logistic model. So if we run the summary command, we get, well, it tells us, hey, this is what you told me to do. And that's a nice reminder. If you're scrolling through tons and tons and tons of models, then it's nice to have that reminder there. But otherwise, we can ignore it. We look at the residuals or the deviance residuals. We'll ignore those, but we would use them to consider goodness of fit, for example. Right, so we could use them, but we're going to ignore those. So far we're ignoring two things, and we're really only focusing on this orange. Sorry, orange. Why did I say orange? It's yellow. This yellow rectangle. Okay, where we get some estimate for the coefficient of the intercept and the slope. Okay. But this is for a logistic model, so we have to manipulate it a little bit. We don't have to do it by hand. We did it by hand last day, but I'm gonna cut that. Okay. Yeah, we did it by hand. I cut that. So that's from last day where we actually plugged things in and looked at it. But today we'll just use the predict function, which does the same thing, just it's able to do it for a lot more inputs at the same time. So we have the estimate for the coefficients. We have the standard errors for those estimates. We also have these Z values and P values. Now, what we see here is the P values tell us if these things that we've put into the model are contributing to the model. Right? Do they help me predict which region they're from? And it looks like, yes, it does, because this is very significant. They have these kind of legends of 3 stars, but if you think of 9.45 times 10 to the -6, that's really, really, really small. So we would reject H0, that this slope is equal to 0, right? And conclude that it's not equal to 0, it's contributing somehow. Okay. I think one thing that I didn't mention last day, and this could get weird, is that the AIC, there are lots of ways that's exactly right. For your practice test one, and I posted the solutions for test 1 as well. And once the test 2 has closed, you'll be able to see your work, see your answers, and see the right answers, and be able to practice new versions of it for test 2, but not until it's closed. Thank you for that reminder. Yeah, so test 1, practice test 1, the 3 assignments, test 2, and that's good for practice. Nice. Okay, so we have other measurements that we could look at, performance measures, but in terms of just what's available here, we can always compare the AIC. And so we want to pick the model that has the minimal AIC available to us. Okay. we can use the Akaki information criterion the AIC as a performance measure to compare logistic models. We pick the model loss functions. I'll have to read up on loss functions. I think so, but I'm not 100% sure. I can't quite remember, kind of on the spot here, loss functions. Anyways, I'd have to look it up, but probably they are all intertwined. So as a performance measure, nice, to compare logistic models, we pick the model with the lowest AIC. So for linear regression or simple linear regression, we can use the R-squared, but remember, we want to maximize our R-squared. So now we have to keep track. Okay, I want a lower AIC. We pick the model with the lowest AIC. Okay, so I'm going to highlight that here. What I'm going to do is I'll kind of call this the end of the review. How about not review? How about we just say from last day? Because it's all kind of running into one another. Okay. I am going to remove some of this that we did by hand last day. Oops. There. Oh, and I guess I could keep that, sorry. Okay, so what we do is once we have our model, right, we could use these coefficients and we could find the logit, and then we can use the logit and we can solve for the predicted probability of a class 1 outcome. Okay, and so we could do that, or we just let R do the work and we use the predict function. Okay. And so I'm going to store it. So what I'm doing here is I'm adding it to the Possum data set. I'm adding a new column called p hat. Okay. And what I want to do in that column is I want to predict using log mod, so that model that I have on the Possum data. Okay. Now log mod is going to look for tail lengths. Okay, so because it's built using a tail length, tail underscore L variable, that's what it goes into this data set and looks for. So it goes into the Possum data. We know there's a tail underscore length variable there. So that's good. So then it goes and it attaches on and it takes each one of those and it gives the predicted response. Okay. And so what I did was I just looked at the head of Possum, and this was very, very, very close to the p hat that we calculated by hand. We had to use, these are likely rounded coefficients, so they're going to be slightly different, but not majorly different. And so we were able to do this one calculation, but it was, you know, a little bit of work. And the predict function just does it for all of them. I think there's 104 possums to make a prediction for, so you'll definitely want to use the predict function. Okay. So we know, just looking at these first 6 data points, they are all from the Victoria region, which means they should all be classified as ones. Okay, but using our predicted probability of being in class 1, we only classify them, we only predict that they're class 1 if the cutoff, if they're larger than the cutoff. Typical cutoff is 0.5. Okay. So I'm going to add here, using this model, these two observations would be misclassified, right? Because this one would be classified as, so here I'll say predicted class, use a cutoff equal to 0.5. That's the intuitive cutoff. You can use other cutoffs if you want to, but the intuitive cutoff is 0.5, right? And so the predicted class here would be, this is more than 0.5, right? So if I told you, okay, the probability, I predict the probability of being in class 1 is 0.59. Okay, class 1. What if it's 0.507? Yeah, sure, class 1. Just sticking to my guns. What if I told you it's 0.15? No, make it a class 0, right? What if it's 0.265? Nah, class 0, right? And then class 1, class 1. So we have these predicted classes. So those two, we know that they are actually in class 1, but they would be predicted to be in class 0. So those would be misclassified. Okay, and so that's another performance measure that we would use. We're not going to have time to get into it, but it is something that we would use, right? And so if we're predicting that they're in class 0, but they should be in class 1, that's an error. On the flip side, if we're predicting that they're in class 1, but they should be in class 0, that's another type of error, right? And so we have errors on both ends. We can look at the overall error, but we'll leave that. Okay. So we looked at the plot, right? And we said, hey, I was expecting a nice, beautiful S curve. What's going on here? So what I did was I made a plot of the pop dummy, which puts me at 0 and 1s here against the tail length. Great. And then I made lines from the p hat going onto the tail. So there should be lines connecting the p hats and the tail data. The problem is this tail data is kind of jagged. So what we did, the trick we used was we generate 500 data points that span between 32 and 43. And then we fill in those points, right? And so we talked about this last day, but it's nice to kind of remember what we did, right? And so we said, okay, new data, I'm going to generate just a separate data frame. It's going to be a data frame, I told it. And what it's going to be is it's going to have one column called tail underscore L. Remember, because the predict function needs something with tail underscore L in it. But now, instead of letting tail underscore L be those individual observations, now we're saying, okay, tail L is actually going to be a sequence running from the minimum tail length in the possum data, so referring to the possum data, up to the maximum tail length in the possum data, and generate 500 of those equally spaced, please. Okay. And so now I have this new data, which is a data frame with one column called tail underscore L. And so what I can do is I shouldn't have used pop. Hindsight, I shouldn't have used pop, but that's okay. So on my new data frame, I generated another column. So now I'm making two columns. I have two columns now. One's called pop, which is going to be the predicted probabilities using the log mod that we had, but applying it to the new data, the tail lengths in the new data, and I want to predict the response. So now if I add those 500 points and I connect them with a line, then I get this beautiful S curve. And this is a model of my probabilities for each value of X. So here's our 0.5 cutoff. Okay, so what we'll see is that, okay, all of these guys, so once I hit this value of X, all of these X's are predicted class 1. Whereas all of these X's are predicted class 0. Right? We see that there's some overlap, so we could be wrong, we could be right, but those are our predicted probabilities. So right, we can use a cutoff of 0.5, and we can assign each of those predictions using their probabilities into class 1 or class 0. So that's kind of where we got to last day, I think. And I see that my print off was cut off here, but I think it just ends with a bracket there. So it didn't get cut off too bad. But what we can do is we consider more than one predictor. The process is going to be the same, except now I'm going to have more estimates, right? More coefficients to deal with. But the idea stays the same, especially the same as a linear model, where we literally add in the predictors that we want. So for example, if I want to include pretty much all the variables, there are fancier ways that you can do this than listing all the variables. You can use a period, which would just throw in all the variables. But what I found was the site, it seems like site number something, 1 and 2 were only in Victoria, and then 3 and 4 and 5 were only in the other region. So then when I included that, it didn't, it just took over the whole model, right? Oh, well, if you know you're in site 2, then I can tell you with certainty that you are in class 1, right? That doesn't help because then you already know where they are or where they're from. So I excluded the site predictor because it was a perfect relationship with the region, I should say. It says the population, but they use population to denote the region. Very confusing. So anyways, so I've called it full log mod. 3 L's in there. So I called it full log mod because it has the full set of predictors. And so, but the same idea, right? The GLM, and I have this pop dummy that I'm trying to predict, but now I'm trying to predict probabilities. And I've included the sex, I've included the age, the head length, the skull width, the total length, and the tail length. And the data is the possum data still, and the family is binomial because I'm still doing a logistic regression. So when I run the summary on this, I get all these coefficients here. And let's see here, let me kind of square that off. Okay. And so what we see, right, I have all these predictors in my model. And if I scroll to the next page here, right, this is a good thing. The AIC, we see the AIC has been reduced. That's a good thing, right? It means we have a better model. Now, often we're penalized for having too many predictors in our model. So what we want to do is we want to have the best model that is the smallest model, the simplest model that performs just as well as this one. So what we can do is we can look at the p-values here, and you know, your eye is guided by these asterisks. Asterisks? No, asterisks. I don't know. And so one thing that I'm going to look at is we see that, okay, the intercept is going to be significant. Even if it's not, you keep it in the model because, again, you need somewhere to start, okay? And so, so we keep the intercept always. It looks like the sex helps us determine the region. I'm not entirely sure if that's true, but it looks like it. What happens is things often change. So the p-values often change when we remove one of the predictors. And so you don't want to remove all of them at the same time. You want to remove them one by one. Okay. And so here, we see, do that all the time, combine my words. We see that the age, the head length, and the skull width are not significantly contributing to the model. We see age, head L, and skull width are not contributing to the model. Are not contributing, I'm going to say significantly to the model. Yeah. What we do is we would remove the least significant variable and then refit the data, right? So refit the model and then come back and then remove the least significant model. Okay. So we can simplify our model. Our model by removing the least significant predictor and fitting the new model. Okay. And so, and fitting a new model. We would repeat this until all of them are significant. Now, right, so here I'm going to say caution. Removing a predictor will likely change the p-values for the other predictors. So that's why you only want to do one at a time. So removing a predictor will change the p-values for the other predictors. So we only remove one at a time. Okay. Backward selection. Yeah, backward selection is when, so we are basically doing backward selection, right? But it's, yeah, backward selection, you put everyone in there and then you pull one out, you see if there's significant, okay, pull one out, exactly. Whereas forward selection is a little bit harder for us to do. Of course, R has these functions built in, but we are doing backward selection, yeah. And good call. I wasn't even thinking of it. I'm like, this is what you do. There's a name for it. Yeah. So that's exactly what we're doing. And so, yeah, here it is in action. Or sort of, I'm just telling you what you would do. Okay, and so then keep removing predictors. Keep removing predictors until all predictors in the model are significant. There's a caveat there as well. Isn't that statistics, right? Well, and there's this one scenario. There are cases where, if you're working with a client, for example, and they say, okay, well, the model, it has to include the age because otherwise I won't know what to do with it. I don't know. In this case, it doesn't make sense. But there are cases where there are variables that have to be in your model, potentially to make it match previous models, that kind of thing. And so there are those cases, but let's just ignore that. Let's be aware that that can happen, but for us, let's ignore it. Okay. So we saw that including all the variables was a good thing for our model, or AIC was reduced. So that's great. But we also see room for improvement, okay? Because we are penalized a little bit with the AIC for having too many predictors in our model. Okay. So we see the AIC has been reduced, and I'll say kind of an orange caution here. Caution. We are usually penalized by having too many predictors in our model. Okay, but for now, let's just, because I didn't run that scenario, can't run every scenario, but we're usually penalized for overfitting the model, which is too many predictors. Okay, so my suspicion would be that if we reduced it to where all the predictors in here are all significant, then we would be able to get an even lower AIC, because here we're being penalized. So they're saying, okay, yeah, great fit, good job, but you're using too much information. You're relying on too much information. And so, right, if you decrease the number of predictors, you can usually decrease your AIC, because then you're rewarded for that, relying on less information. So if I use the predict function again, and I've called it full p hat, I don't know, full model, full log mod, full p hat, I don't know, it made sense at the time. And so I've created a new column for this these predictions with the full model. And so now I'm using the full log mod on the possum data, and I'm predicting the response. So now we can compare these predictions and notice that all of these are correctly classified as class 1. That's a good thing. We overfit the model, but we're able to get these pretty good predictions. The problem with overfitting is that, well, this is just based on this data set, right? What if you have a brand new data set that you haven't seen before, or rather that your model hasn't seen before? When you apply it there, you might not get the same results, right? And so the fit might not be as good if you're relying on too many pieces of information. But for right now, it's doing an awesome job predicting. And so all are, or I'll say all 6, because there's 104, but I'm just showing the head. All 6 are correctly classified. That's a good model. I think it's the last option I want to show you. Yeah, is if we suspect that 2 predictors change together, okay, which is not unreasonable to think. For example, if the tail length, if we figure the tail length, well, maybe the males are just bigger in general. So not just the tail length, but if we kind of bring it back down and we focus on just the gender and the tail length, what we can do is we can incorporate an interaction term. Okay, so here, if we suspect that 2 predictors change together, right? So if the gender changes from female to male, then we expect that the tail length would go from shorter to longer, presumably, right? Let's assume that the males are bigger. That seems to be, you know, a typical trend. And so if we suspect that's something that's happening, we can capture that in our model, okay? So that's called an interaction. Okay. And so I've made this interact log mod. Names are getting longer and longer. And it has the same setup. And I'm going to zoom in just a little bit here. I'm focusing on just the gender, so the sex and the tail length. So what I can do is I can have the sex and the tail length individually, and then have the interaction term. There's an even easier way to do it. But if I do variable or predictor 1 colon predictor 2, then it looks at the interaction between the 2. But really, interaction is a literal multiplication of those 2 variables. Multiply predictor 1 by predictor 2. Okay. So what the output is going to look like is like this. Okay, so again, we can kind of ignore the top stuff here, and we're going to focus on the coefficients. We're a little bit bummed because our AIC seems to have increased a little bit, but we want a smaller AIC. And now I just want to confirm, I'm going to scroll up to the top real quick and just confirm that that's what I said, because I don't want to. Phew. Okay. I just had one of those moments where I'm like, is that what I said or what? Okay, so if we look at an interaction term, then what we have, and here I'm going to highlight this, the coefficients again. So what we have here, if we write out this model, we have the class, which is the region, or maybe I'll say the model, just for simplicity's sake, is going to be 27.2891 plus 5.7538. Uh-oh, gonna need more space. Where can I do that? I made a mess now. Okay, times the sex M minus 0.7259 times the tail length minus 0.1948 the sex m times the tail length. Okay. Maybe what I'll do here, how can I add a page? I'll add a page here. And then what I'll do is I'm going to copy this chunk, and you can ignore it because I'm going to paste it down here. Oops. I'll make it bigger, but that's good. Because I want to show more of this here. Ha. Okay. Ha. Paste image. All over the map today. Okay. And let's see if I can't just drag this down here. I don't know why I'm hanging on to it. It wasn't that beautifully written to begin with, or at all. But there. Okay, so let's talk about these, because the sex m is a dummy variable itself, right? And so here, this is 1 if male, presumably 0 if female. Okay, the tail length is just a numerical variable, right? And so what I want to do is let's go ahead and we know the tail length of the first observation, right? Let's try to mimic that first line in our data set, and let's see how we would use this model. So let's figure out what the gender is for that first possum. And I think I have it. Where's that data set? Here. This first possum we know it has a tail length of 36, so we'll use that again. And we're going to try to match this interaction p hat that we're developing. Okay, but for now, right, let's focus on, okay, we've got a male possum with a tail length of 36. Use the model to predict the probability that the first possum in the data set is in class 1. We're always, the probabilities that we're talking about are probabilities of being in class 1. Okay. And so for our first, let's see if I can copy. So our first little guy is male and has a tail length of 36. Yeah. So our logit of p hat is going to be, so we can write the logit, because I wrote the model because I was trying to avoid kind of getting too technical, but we can handle it. The logit of p hat, which is the model, is, and how about this? I'm going to copy this. Copy. Shrink it down because I wrote too big. So it's going to be 27.2891 plus, now it's going to, sex M is going to be a 1 because it is a male, right? It would be 0 if it was a female, right? And so here, plus 5.7538 times 1. Okay, so that's what we're going to do. So it ends up being exactly what it looks like in your model, right? It's a little bit weird in the beginning, but it is exactly what it looks like. You just multiply those two predictors. So minus 0.7259 times 36 minus 0.1948 times 1 times 36. Okay, I can do that. I'm going to simplify this because just to make sure I don't hit a snag somewhere, 5.7538. And then I'm going to do 36 times 0.7259 minus 26.1324. And well, what's nice about having an indicator in your interaction term is if it's on, then you're multiplying by 1. So it's just times 36. If it's off, it's even easier, right? If it's a 0, then it's 0 times 36, and then this whole term goes away. So that's nice. So 26.1324, and then 36 times 0.1948 puts me at minus 7.0128. So if I add this up, 27.2891 plus 5.7538 minus 26.1324 minus 7.0128. Nice try. I almost flubbed it. Maybe I did, but I'm getting negative 0.1023. So remember, now we can take this logit of p hat, which is really just a placeholder for b0 plus b1 x1 plus b2 x2 plus b3 x1 times x2. In this case, we didn't introduce the model like that, but that is what it looks like generically. And so now I can take this model and I can use I can solve for p hat. Recall p hat is 1 divided by 1 plus e to the negative logit of p hat. You can use I noticed on the assignment, they show you a different version where it has e to the logit, so not the negative. Right here, this is the negative, so it's a little bit easier, I find, if you're just able to use the negative. Or if you don't want to negate it, then it's e to the power of that over 1 plus e to the power of the logit. So what we have here is we have p hat is going to be 1 divided by 1 plus e to the negative 0.1023. Oh. 0.1. Oh my gosh, did it again. 23 there. So if I run this on my calculator, I get e to the power of negative what I had on my screen, and then 1 plus that, and then 1 divided by that. I get a p hat of 0.47444728808. And I should use approximately equal to because I'm sure I've rounded somewhere along the way. Okay. So before we compare our values here, let me crop this. what we could do is we could get a little bit sneaky. And if we use the actual multiplier, right, you might have been wondering, hey, why don't I just multiply it? And that's because if you're doing an interaction term, you have to have the individual values in there, okay? And so you have to have the individual predictors in order to do the interaction term. So as a shorthand in R, when we do sex times the tail length, R knows that, okay, well, yeah, I'll do that interaction, but I'll also include the individual predictors. Okay, and so this is kind of I don't know, not easier, but it's a shorthand version of it. So I called it interact to log mod because they get the same results, right? And so here when we use predictor 1 times predictor 2, it automatically adds the individual predictors because they need to be in there in order to consider the interaction term, because they need to be in there in the model in order to consider the interaction. I don't know, it doesn't seem like that much to ask, but they have to be in there, right? And so we notice that the interaction term isn't actually contributing, only the tail length is here. And so this is not a very good model. The output is the same, so the AIC is going to be the same as before, and the coefficients are going to be the same. It's just another way of entering the model, that's all. And I wanted to highlight that you can have you can't have an interaction without the individual predictors. And to finish us off here, if I compare this value here, copy, paste, and make it pink. How about that? Versus 0.4744320, right? Close enough because we had to use rounded values, right? But 0.4744, that's pretty good, right? We had to use rounded values, right? We used what we had in the output, but the output is always going to be rounded a little bit. So the odds ratio to calculate the probability. So we worked through that last day, but because I'm out of time, I'm happy to take you back to those notes. But I want to say that concludes our material, and good job. And it's been my pleasure having you in class, and I hope that you have a good final exam time. So that concludes the course. Oh my gosh, can you believe it? Great work. Okay, so If you're curious about the odds ratio, then stay tuned. Otherwise, I'm going to end this recording here, and good luck on the test tomorrow. I have no clue how many on the final exam, but I'll probably test 1 plus test 2 and then take away 2 or 3 questions, probably, usually. Just thinking about the timing for both of them. So around there, yeah. But basically, test 1, test 2 together. Yeah. Okay. Great job. Good job working through that. And good luck on the test tomorrow. I'm going to finish this recording.